When it comes to measuring lengths with accuracy beyond the meter scale, we need specialized instruments. Everyday rulers and tape measures are great for rough measurements, but in fields like engineering, manufacturing, and science, even a millimeter can make a significant difference. That's where advanced length instruments come into play. In this video, we'll explore two essential tools, the Vernier Caliper and the screw gauge. These instruments allow us to measure with remarkable precision, making them indispensable for anyone who values accuracy in their work. Let's start with the Vernier Caliper. This tool is designed to measure internal and external dimensions, as well as depths, with much greater accuracy than a standard ruler. Its unique construction allows for readings down to fractions of a millimeter. Whether you're measuring the diameter of a pipe or the thickness of a small object, the Vernier Caliper is up to the task. Its versatility and precision make it a favorite in laboratories and workshops alike. Vernier Caliper consists of several key parts: the main scale, the vernier scale, inside and outside jaws, and a depth gauge. The main scale provides the primary measurement, while the vernier scale allows for fine adjustments. The inside jaws are used for measuring internal dimensions, such as the diameter of a hole, while the outside jaws measure external dimensions. The depth gauge is perfect for measuring how deep an object or cavity is. Each part plays a crucial role in ensuring accurate measurements. One of the most important concepts in precision measurement is the least count. For a vernier caliper, the least count is typically 0.1 or 0.01 cm. This means the smallest measurement you can reliably read is a tenth of a millimeter. The least count is calculated by dividing the smallest division on the main scale by the number of divisions on the vernier scale. This fine resolution is what sets the Vernier Caliper apart from ordinary measuring tools. Zero error is a common issue in precision instruments. For the Vernier Caliper, zero error occurs when the jaws are closed, but the zero marks on the main and vernier scales do not align. This misalignment means your measurements could be off unless you apply a correction. Identifying and correcting zero error is essential for ensuring the accuracy of your readings. Always check for zero error before taking any measurements to avoid mistakes. Zero error can be positive or negative. A positive error occurs when the vernier zero is to the right of the main scale zero, while a negative error happens when it's to the left. Recognizing the type of error helps you apply the correct adjustment to your measurement. This step is crucial for achieving true precision, especially when working with very small tolerances. Take a measurement with a vernier caliper. First, note the main scale reading just before the zero of the vernier scale. Next, find which vernier division aligns exactly with a division on the main scale. Multiply this number by the least count and add it to the main scale reading. Don't forget to apply any necessary correction for zero error. This process ensures you get the most accurate result possible. Now let's move on to the screw gauge, also known as a micrometer screw gauge. This instrument is designed for even finer measurements, capable of reading up to 0.01. It's especially useful for measuring the diameter of wires or the thickness of thin sheets, where extreme precision is required. The screw mechanism allows for very small, controlled movements, making it ideal for delicate tasks. The screw gauge operates on a simple principle. As you rotate the thimble, a finely threaded screw moves the spindle forward or backward. The pitch of the screw is the distance the spindle moves with one complete rotation, typically 1. The scale on the sleeve and the rotating thimble together allow you to read measurements with incredible accuracy. This design makes the screw gauge a staple in precision engineering. The least count of a screw gauge is typically 0.01. This is calculated by dividing the pitch, which is the distance moved per full rotation, by the number of divisions on the thimble, usually 100. This fine resolution allows for extremely precise measurements, making the screw gauge ideal for tasks where even the smallest error matters. Just like with the vernier caliper, the screw gauge can also have zero error. This occurs when the spindle is fully closed against the anvil, but the zero marks on the scales do not align. It's important to check for zero error before taking any measurements and to apply the necessary correction. This ensures that your results are as accurate as possible, especially when working with tiny dimensions. The screw gauge is commonly used to measure the diameter of thin wires and the thickness of metal sheets. Its high precision makes it perfect for tasks in electrical engineering, jewelry making, and scientific research. Whenever you need to measure something extremely small with confidence, the screw gauge is the tool of choice. While digital versions of both vernier calipers and screw gauges are now available, learning to use the manual versions is invaluable. Manual tools help you understand the underlying principles of measurement and develop a keen sense of precision. Mastering these skills lays a strong foundation for using more advanced digital instruments in the future. Precision is crucial in many fields. In engineering, a small error can lead to parts not fitting together. In science, inaccurate measurements can affect experimental results. Manufacturing relies on exact specifications to ensure quality and safety. That's why mastering these advanced length instruments is so important. They help you achieve the level of accuracy required for professional results. Sum up, vernier calipers and screw gauges are essential tools for anyone who needs to measure with high precision. Understanding their parts, how to read them, and how to correct for errors ensures you get accurate results every time. Whether you're working in a lab, a workshop, or out in the field, these instruments will help you achieve the precision your work demands. Remember, in the world of measurement, every millimeter counts.